Today we're going to be simplifying non-perfect squares and cubes. Yesterday we estimated non-perfect squares and cubes. You're going to need to be able to do both skills for geometry and be able to express your answer both ways, simplified and estimated. Let's take a look at an example. Simplify the square root of 180. So we need to simplify the square root of 180. To do that, I think it's easiest to make a factor tree. If you remember factor trees, you branch off with factors that multiply together to give you the number. And we stop our branches at prime numbers. So the easiest way to start this one would be 18 multiplied by 10. And of course, you can do your factor tree any way that works for you. 18 could branch off with a 2 times 9. 9's prime, I'll circle it. 9 could branch off with a 3 times 3. They are both prime. 10 could branch off with a 2 times 5, and they're prime. Now, being that I'm finding the square root, I can look for numbers that appear twice or that are squared. So if we take a look here, I have a set of 3's, and I also had a set of 2's, and then I have a 5 that's just all by itself. Looking at the sets, I know that 2 squared is equal to 4, and I know that 3 squared is equal to 9. 5 is all by itself. Therefore, I can break down the square root of 180. I know that the square root of 180 would be equal to the square root of 4, because that answer is 2 times 2, times the square root of 9, because of my 2 3's, and I have a 5 by itself, so times the square root of 5, which I can't simplify anymore. So 2 times 3 times the square root of 5. That can simplify a little more into 6 times the square root of 5. Therefore, my simplified version of the square root of 180 would be 6 times the square root of 5. Here's another example. Let's simplify the square root of 363. I'm going to take 363 and make a factor tree, and I'm going to look for pairs of factors. Being there's a bunch of 3's, I'm going to branch off with a 3 times 121. 3 is prime. 121 I know is the factors 11 multiplied by 11. They're both prime. And now automatically I can see I have a pair of 11's. 11 squared is equal to 121. Therefore, I know that the square root of 363 is equal to the square root of 121 times, and I have a 3 all by itself. So multiplied by the square root of 3. The square root of 121 is 11. Multiplied then by the square root of 3 because I can't simplify that anymore. And now I have my answer. The simplified square root of 363 equals 11 times the square root of 3. You can do the same method with cubic roots, but when you do it with cubic roots, you're looking for sets of 3 numbers that appear in your factor tree, because cubic root is a number multiplied by itself 3 times. So I need the cubic root of 135. Do a factor tree. It ends in a 5, so I know 5 would be a factor. It goes in 27 times. 27 could branch off with a 3 times 9. 3 is prime. 9 could branch off with a 3 times 3. And now I see a set of 3 3's, or a group of 3 3's. 3 cubed is 27. Therefore, I know I can start breaking this into The cubed root of 135 would be equal to the cubed root of 27, which I know is 3, times the cubed root of 5, because 5 is all by itself here. I can't simplify the cubed root of 5 anymore. Therefore, my simplified version of the cubed root of 135 would be equal to 3 times the cubed root of 5. Let's do one more example. I need to simplify the cubed root of 3,240. Start with a factor tree of 10 times 234. 10 could branch off into 2 times 5, and they're both prime. 324, I know, could branch off into 3 times 108. 3 is prime. 108 could branch into a 9 times 12. 9 could branch into 3 times 3. The 3's are prime. 12 could branch into 3 times 4. 3 is prime. And 4 could branch into 2 times 2. And of course, the 2's are prime. So I'm going to look for groups of 3 numbers. I have 1, 2, 3 2's. 2 cubed is equal to 8. Therefore, to start simplifying this, I can think of the cubed root of 8 times. I also have 3 3's. 3 cubed is 27, so times the cubed root of 27. And then notice I have a 5 and a 3 left, which equals 15. So multiplied by the cubic root of 15. The cubic root of 8 is 2. The cubic root of 27 is 3. And I can't simplify the cubic root of 15 anymore. 2 times 3 is 6 times the cubic root of 15. So now I've simplified. The cubic root of 3,240 equals 6 times the cubic root of 15. So now I've showed you yesterday and today how to do both estimating squares and cubes of non-perfect square roots and cubic roots, and also simplifying non-perfect squares and cubic roots. You'll need to do both when expressing your answer in geometry.